Nature is not static. Water, waves, light. Everything is in motion. Scientists in Hamburg aim to get to the bottom of these dynamics. They want to watch how the smallest particles move, such as atoms, molecules, or electrons, and in so doing, create something huge. Because what you can see with your own eyes, you can analyze, understand, and one day hope to accurately control. Hamburg offers an excellent infrastructure for this kind of fundamental research. There are extraordinary X-ray, laser, and synchrotron facilities. A large number of prestigious scientists have joined the Cluster of Excellence, the Hamburg Center for Ultra-Fast Imaging. They want nothing less than to make their scientific dream come true, to create a molecular movie. This movie could open the door to a new way of understanding nature, and this knowledge will enhance our ability to address pressing medical and technological questions. This will change our world. This is CUI.
My name is Horst Weller. We are doing here research on the synthesis and application of nanocrystals, and I'm one of the spokesmen of CUI. So we are synthesizing nanocrystals since many years, and there is one basic question in this research field, which is how do these small nanocrystals evolve in a solution? First of all, there is a nucleation process where some atoms come together and then they grow to a nanocrystal. And we want to understand which parameters influence this nucleation and growth processes. So we have a lot of laboratories where we test different chemical reactions to produce these particles and to modify these particles for applications, for example in displays or for medical application in diagnostics and molecular imaging and drug delivery. And we have some laboratories where we look for the structure of these materials which we produce. And within the Cluster of Excellence, we are looking for the process, how they evolve these particles and how we can influence these processes, what finally comes out during the synthesis.
My name is Philipp Wessels. I'm a postdoc in the CUI and I work on a physics research project. Personally, I like that the conditions in the CUI are quite excellent and that the research project is really interesting and fascinating. And that for the first time we can combine here the two worlds of ultrafast physics and quantum gases. And it's really exciting to see what will come out of this project and what we learn about these topics. At CUI there is the possibility to be involved in an extensive educational program within the graduate schools. You have the ability to participate in the soft skill courses and gain, for example, knowledge in computer languages. There's also a great deal of financial support for visiting conferences, international conferences, and for inviting international experts from the PhD student in a lab up to Nobel Prize winners to invite these people to Hamburg and to share experiences with them. This is enormously helpful for young scientists to get in touch with the international community or science community.
Hello, I'm Arwen Pearson. I'm a professor at the University of Hamburg and part of CUI, and I'm a crystallographer and structural biologist.
And we're interested in understanding how molecules and proteins work in the body, but at molecular level. So we use physical tools like X-ray crystallography to directly image the molecules and see how the atoms within them are arranged. What we're really interested in understanding is how these molecules work. So it's all very well taking a single snapshot of the system and seeing it at rest. But what we really want to be able to do is to watch that system move. So in our group we're developing methods to do those kind of time-resolved measurements, and There's now lots of possibilities at DAISY with Petra and XFEL to actually do really fast time-resolved measurements to see how a molecule moves with time, how it behaves dynamically. My group is interdisciplinary. We have biologists and chemists, and a physicist will be joining the group. So within the group itself we're interdisciplinary, and then we work in this much wider interdisciplinary environment. And I think without that, the kind of science we're interested in doing would just not be possible. And what I find great here at CUI is this is really done in a conscious way, so there's a number of programs really there to encourage female scientists to get involved in science and to stay in science. We have a mentoring program together with DAISY and the Universität, which looks to put together young female scientists with more established female scientists to help them navigate. And being part of the Centre for Ultrafast Imaging is brilliant, and the developments that are coming on the Barneveld campus are, I think, sort of unique worldwide. The investment that's come into instrumentation, into the new sources, is incredibly attractive.
My name is Klaus Sengstock. I'm speaker of the Excellence Cluster CUI, and at the same time we perform research on fundamentals of the dynamics of atoms. Wir untersuchen die Grundlagen.
We investigate the fundamentals of dynamics of atoms when they are almost at rest and the laws of quantum physics apply. This is important because this works hand in hand within the cluster. We investigate fundamental processes that appear when atoms gather that form molecules and brand new functionalities develop.
Wie ihre Funktionalität ist. Und dies wird dann weitergeführt.
This is followed up by colleagues within their research groups to then see how bigger molecules interact and see their importance for life. They'll be applied into nanostructures that have many applications.
Strukturen, die dann sehr viele Anwendungen haben. Innerhalb unseres Forschungsclusters.
Within our cluster we combine physics, chemistry, biology and medicine. We work at this interface of the field of research together in teams. These teams have 3, sometimes 10 or 20 people. This is how modern research works.
Und nur so funktioniert moderne Forschung. Und dadurch, dass es eben ganz...
And with this important aspect, young scientists especially have the chance to work at the interface of different sciences and to get to know the expertise that is highly represented in Hamburg, to develop and to practice a totally new science.
Damit ganz neue Forschung betreiben zu können. Es ist uns wichtig.
It's important to us to bring modern science, modern research closer to the students, especially young people.
Wir möchten mit unserem Schulprogramm gerade auch die erreichen.
With our school program, we want to essentially reach the public that won't work in science, but as lawyers, doctors, or politicians. They'll remember this and say, hey, that is modern research. And that's what it looks like.
Hey, das ist moderne Forschung. So sieht es aus.
I am Melanie Schnell and a project leader at CUI and a group leader at the Max-Planck Institute here in Hamburg. So we want to study how 2 molecules bind to each other. And this aims at understanding this basic process of molecular recognition, which is kind of the heart of all the biology going on in living systems. So if you have an enzyme, for example, it has an active center, and these molecules will very specifically be recognized and bind to this active center. And so it's not yet a priori possible to predict what kind of molecules will bind to this active center and how they do this. And so our research aims of shining more light onto this underlying process of molecular recognition. And we even now want to have an office, the parent-kid office, here in the CFAL building, so that you can even go into this office when you don't have an office on your own. So that the project work, which is also coming with some deadlines and milestones, that this project work nevertheless can continue. Or raising awareness that, for example, when we have a symposium that goes over the weekend, that we organize childcare for that.
Hello, I'm Dwayne Miller. I'm a director for the Max-Planck Institute for the Structure and Dynamics of Matter and a spokesperson for CUI. Our quest has been to be able to get a direct atomic view of chemistry and biology in action. And every time we've done this, we've always seen a surprise. What we thought was the way something happened isn't the way it happened at all. And every time we do this, there's an important lesson to be learned. And if you look at CUI, the structure is unique. We have a very interesting facility, the European XFEL, we have Petra 3, we have DAISY, we have a number of world-leading experts from areas from ultra-cold atoms. We can understand basic physics. And so when you think about the kind of different science that's brought together here in Hamburg through CUI, I think that is really unique worldwide. And that CUI is making an impact. It's going to help us understand biological systems, quantum physics. So I would say if you give me a 10-year, 20-year perspective to guess where we could go, I think we're certainly going to understand how biological molecules work at the individual molecule level. That answers 2 of the 3 questions of a living system.
Scientists from all over the world have come together in Hamburg to perform future-oriented research. Physics, chemistry, and molecular biology. Basic research that reaches beyond subject boundaries and institutes. Working side by side are some of the best scientists of Universität Hamburg, the Deutsches Elektronensynchrotron, the Max-Planck Society, the European XFEL, and the European Molecular Biology Laboratory Hamburg. A gateway to science. This is CUI.